A radical expression, the square root of m, is only defined for values of what? Can it be 0, I guess is saying. So m greater than or equal to 0. You should know that from your restrictions from grade 11 pre-cal. This is because the square root of a negative number is not defined. That's when we get into the complex number system and we talk about imaginary numbers. Okay, a radical function is a function that involves a radical with a variable in the radicand, which is inside the root. It has the form of y equals the square root of f of x, where f of x is a function. So the first thing we have to know is determine values of x where it's defined. So that means whatever's inside the radical has to be greater than or equal to 0. So 21 minus 3x has to be greater than or equal to 0. So what do we do to figure out what x has to be? Move the 21 over. We have negative 3x is greater than or equal to negative 21. Okay, so this is the part that people forget with an inequality. When you're doing algebra and you're multiplying both sides or dividing both sides by a negative number, you need to switch the inequality sign. So this becomes x has to be less than or equal to positive 7. So think about that for a second. If I were to put something that's bigger than 7 in here, would you not get a negative number? Like, for instance, 8. If I put 8 in there, so does it make sense why I'm switching my sign? Yes? Okay, so how about a quadratic? That means x squared minus x minus 12 has to be greater than or equal to 0. Oh, do you remember her doing this in grade 11 pre-cal? We don't remember. Well, this is where we did a sign diagram. This is where you were first exposed to a sign diagram. So what you should have done is you factor this. So you get x minus 4 times x plus 3, right, is greater than or equal to 0. Then you do a sign diagram with what on it? 4 and negative 3. And then you do pick a number on the left of negative 3. So what? Negative 1,000,000. So if you put a negative 1,000,000 in the first factor, what will you get? A negative. If you put negative 1,000,000 in the second factor, what will you get? Negative. And a negative times a negative gives you a positive. So something between negative 3 and 4. 0. So what do you get in the first factor? Negative, positive. So that would be negative. And then let's pick something bigger than 4. A billion. If a billion goes in there and a billion goes there, what do I get? A positive times a positive, which gives me a positive. So what's my answer for this? Negative infinity. I'm looking where it's positive, right? Negative 3, does it include negative 3? Yes, because it's equal to 0 as well. And then union. 4 to infinity. So there's my solution right there. You could have said x has to be less than or equal to negative 3, or x has to be greater than or equal to 4. Yes? It's easier to do it in interval notation. Okay, so we're going to graph these. The first thing is you don't probably know what a square root graph looks like, so let's pick some numbers. So what should I start with? 0, 1. Should I pick 2? No. Probably not, because I can't square root 2 nicely. So what? Yeah, 4, 9, 16. That's probably good. Okay, so then I'm going to plug this in. What do I get for my points? 0. What do I get for that? 1. What do I get for that? 2, 3, 4. Okay, so this will be forever known as our base radical graph, so you need to know what this looks like. So 0, 0, 1, 1, 4, 2, 9, 3. And I can go on and on. Do you see what it looks like? It looks like a half of a parabola going the other way. doesn't it? Does anybody think they know why it looks like a half of a parabola going horizontally? Because it is a parabola? Yes, if I had the other part of it going this way, then I would have the horizontal parabola. That would be in the form x equals y squared, which is one of the enrichment topics. Okay, so what's my domain? 0 to infinity. What's my range? Same thing, right? Yes? Okay, so what do you think is going to happen here for B? I hear shift, what? Down 1. That is correct. But say you didn't realize that the first time, but you guys are expert graphers, so you don't even need to fill in a table of values. Let's just do it for fun. 0, 1, 4, 9. So if 0 goes in, the square root of 0 is 0. 0 minus 1 is minus 1. So do you see it's going down 1? 1 goes in, the square root of 1 is 1. 1 minus 1 is 0. So that gets shifted down 1. So you're absolutely correct, the person that said it gets shifted down 1. 4 goes in, the square root of 4 is 2. 2 minus 1 is 1. 9 goes in, the square root of 9 is 3. 3 minus 1 is 2. So do you see it's exactly the same graph. Y equals the square root of x minus 1. Okay. Yeah. Yeah. Okay, how about the next one? I hear left 2. Very good. Oh, we didn't do domain and range. Sure. So what's the domain? 0 to infinity. What's the range? -1 to infinity, which makes sense. If it got shifted down 1, that would only affect the range, right? Okay, next one. I heard it's going to be shifted left 2. That's absolutely correct. So let's just pick some that are left 2. So that would be -2, -1, 2, 7. So -2 goes in there. -2 plus 2 is 0. Square root of 0 is 0. I should do this in a different color. Hold on, I'm going to switch my color here. I'll make it purple. Okay, -1 goes in there. -1 plus 2 is 1. Square root of 1 is 1. 2 goes in there. Square root of 4 is 2. And 7 goes in there. Square root of 9 is 3. So -2, 0. -1, 1. So everybody can see visually it is left 2. Yes? So again, we're not going to do this by table of values. Once you know what the first graph, base graph looks like, that's the way we're going to graph it. It's much faster. Yes? Okay. So domain is -2 to infinity, and the range is 0 to infinity. Makes sense. If it goes left 2, it's only affecting my base graph, right, at the domain. Okay, so now we're just going to use transformations to do this. I don't need to justify to you through a table of values what happens. When I have the 2 on the left side, what should I do? Yeah, we can see more this way. So can anybody give me the description of what happened here? Right 3, down 2. Okay, so we're going to start with our base graph. Remember what a base graph is? 0, 0, 1, 1, 4, 2. Yes? 9, 3. There's my base graph. So I'm going to change color here. We're going to take those 4 points or 3 points, and we're going to go right 3, 1, 2, 3, down 2, 1, 2. Right 3, 1, 2, 3, down 2, 1, 2. right 3, 1, 2, 3, down 2. So this is y equals a square root of x minus 3 minus 2. I don't know why there's that additional dot right there. Oh, we have to do domain and range. Okay, sorry. Domain and range. What's my domain and range and the x and y intercepts? So domain is 3 to infinity, yes? And my range is -2 to infinity. And my x-intercept is 7. And my y-intercept, none. Okay, what happens on the next one? Yes, vertical stretch factor 4, then left 2. I'll use green this time. Okay, so 0 gets stretched 0, right? Then left 2. Everybody got that? So if it's a vertical stretch, I'm looking at the y values, right? So this is a height of 1. It gets stretched. So now what is it a height of? 4. And then it goes left 2, 1, 2. This is a height of 2. It gets stretched 4 times. So what is it going to go to? 8. Then left 2, 1, 2. Yes? Y equals 4 root x plus 2. Is everybody good with that? Okay, so domain and range. What's the domain? -2 to infinity. What am I doing? -2 to infinity, and my range is 0 to infinity. My x-intercept is -2. My y-intercept is, ooh, not quite sure. So what do I do then? You plug in 0 for your x. So what do I get? Huh? 4 root 2? Yeah, so 4 root 2. Exact values, right? Everybody see that? Plug 0 in for x. 0 plus 2 is 2 root 2 times 4 is 4 root 2. Okay, moving on. We're going to start with a base graph again. 0, 0, 1, 1, 4, 2, 9, 3. Yes? Okay, we're going to move the 3 over. So y equals the square root of 2 minus x plus 3. What else do we have to do for this one? We need to factor out the b. Does everybody remember that? Nothing's changed here. So negative bracket, the b is -1. So it's going to be x minus 2 plus 3. So can anybody tell me what happened here? So it's a reflection, not a flip, a reflection over the what? Over the y-axis. It's affecting the x, right? Then it's what? Yeah, then right 2, up 3. Yes? Okay, let's do it. Reflection over the y-axis. 0 stays as 0. Then I'm going right 2, 1, 2, up 3. 1, 2, 3. Yes? Next one. 1 gets reflected over to -1. Then I'm going right 2, 1, 2, up 3. 1, 2, 3. The 4 goes to -4, then right 2, 1, 2, up 3, 1, 2, 3. Okay. Before I go on, I just thought of something here. If we go back to this base graph here, I know I only picked 0, 0, 1, 1, 4, 2. But what happens if I were to pick fractions between 0 and 1? The way I drew it here, it looks like it's going straight there. But if I were to actually pick something that's a fractional thing, like for instance, 1/4, that would become 1/2. So if I were at 1/4 here, I would be at 1/2. Do you see it actually goes like this? Do you see what I'm saying? And so we need to fix that up a little. So this was asked on the exam before, where they had a graph like this and the person went like this and it went like this. And they say, what's wrong with this graph? And what the problem is it's almost like they want you to have it exasperated above the y equals x. Because it is, when you square root fractions, it's actually, you get a bigger number than a smaller number. Whereas here you get smaller numbers, right? So then it goes like that. So just be careful when you draw your square root button, your square root graph. It's not diagonal, it's above the diagonal, and then it goes below. I know it sounds picky, but that's what they want to see there. Okay? So I'm just looking at mine here, and it looks very diagonal, and it shouldn't be, so I want to fix it up so it's going like that more. Do you see what I'm saying? Okay, so anyways, I still have to do my domain and range. What's my domain and range here? What's my domain this time? Negative infinity to positive 2. My range is a height of 3 and up, right? So 3 to infinity, yes? What's my x-axis intercept? None. What's my y-intercept? What's my y-intercept? No, it's not a guessing game here. You plug it in. Yes, √2 plus 3. Okay. So, next one. Next one. Can anybody say what happened here? I'm sorry? Reflection over x-axis. Very good. Horizontal stretch, not a factor of 2. Stretch factor 1/2. Ooh, we forgot that from the first unit. Huh? Compression factor 2. But remember, our x's are getting halved, right? So yes. Okay, so 0, 0 gets reflected over the x-axis. Then it's still 0, 0. Then it gets stretch factor 1/2. It's still at 0, 0. Yes? Okay, 1 gets reflected over the x-axis, so now it's at a height of -1, yes? And then my x value gets compressed, right? So it's halfway now, yes? So 4, 2 reflected becomes 4, -2. Watch on this graph, this -1 looks kind of whatever there. So it's at 4, -2, and then it gets halved, so now it's at 2, -2. Does everybody see that? And then let's do 9. 9, 3 becomes 9, -3. Then half of 9 is 4 1/2. So there you go. So do you see how it's going like that? Okay. What's happening here? It's going there. 4, 3. 9, 5. 4, 3. 1, 1. And it was 0, 0. You know. So what's going on here? Actually, this one now is down here, right? So It's at 0, negative 1. So it looks like it got shifted down 1, yes? Or did it? No. What's going on here? You have no clue? There's a stretch. There's a stretch. Well, when you stretch it, this would show how much it goes down afterwards, right? So that doesn't make sense? So what's going on here?
Maybe it went 2 and then down.
Well, it could have been from 9. So for instance, 9, 3.
So I think from 3 to 6 and then down 1 to 5. So that's the only way 1 and 1.
3 to 6 and then down. Yes. Look at that. So 4, 2 got stretched double, then down. 1, 1 got doubled and then down. So how would I write that? Very good. That was a hard one to see. So what would it be? It got stretched vertically, so that would be 2 root x and then down 1. So minus 1, yes? Okay, how about the next one? So 0, 0 compared to that. 4, 2 compared to that. And 9, 3, it looks like compared to that. So it looks like it's going left 2 each time, yes? And is it just going up? Up 3, 1, 2, 3. Up 3, 1, 2. Uh-oh. Nope. 1, 2, 3. Oh, yeah. Yeah. Okay. Oh, I don't know what I'm saying. Okay, so y equals, so what is it? The square root of x plus 2 up 3, right? Bada bing, bada boom, boom.